ancient Greek philosopher Democritus looked at the world, he imagined everything, from the crunch of bread to the glow of stars, was made of tiny, solid bits. He called them atomos, meaning uncuttable, indivisible. To him, atoms were the ultimate building blocks, the cosmic grains of sand from which reality was poured. Fast forward nearly 2,000 years, and we're still on the hunt for the tiniest particle of matter. Scientists have discovered a wealth of particles, but the quest for understanding what everything is made of continues. The idea of Democritus's atoms will hover over the heads of physicists for a long time to come, and it all started 200 years ago. By the early 20th century, the atom began to crack. First came the electron, a tiny spark pulled from matter with electric currents. Then Ernest Rutherford fired particles at gold foil and discovered that atoms were mostly empty space. Later, protons and neutrons emerged, clustered in the nucleus like bustling citizens in a tiny city-state. The indivisible had become divisible. Protons and neutrons shattered further, revealing quarks dancing inside like restless children, never found alone, bound by the strongest force in the universe. Electrons weren't lonely either. They belonged to a sprawling family called leptons, and all around them swarmed messengers, photons, gluons, W and Z bosons, carrying forces across the quantum landscape. The atom was no longer a simple bead, but a complex system. If Democritus had lived today, he might have imagined a different story. Instead of grains of sand, he would see the universe as a vast language. Not a language of letters and words, but of particles, and not just any particles, but the ones collected in a cosmic cheat sheet our physicists call the Standard Model. Where the ancient atom was a single, indivisible noun, the modern atom is a sentence built from dozens of characters, each with rules about how they pair, interact, and change. Quarks form protons and neutrons, the way letters form syllables. Electrons orbit like punctuation marks. The Higgs boson, discovered only recently, is a kind of grammatical glue, giving particles mass so they can form stable structures at all. In this analogy, the atom is no longer the fundamental unit of matter, but a word, constructed from a deeper alphabet of subatomic glyphs. The Standard Model provides the grammar book. It tells us quarks combine to form the matter in nuclei. Leptons, like electrons, occupy space around them. Bosons carry forces, allowing particles to talk. The Higgs field gives weight to the conversation. Everything we see, from mountain ranges to neural networks, emerges from these rules, written in a script older than stars. As technology sharpens, layers peel away, revealing even richer complexity beneath. Scientists today wonder whether quarks may themselves be composed of smaller entities, prions, or whether space-time itself is built from something even more fundamental. The story of the atom is not one of simplicity fulfilled, but simplicity undone. Yet there's something poetic in this endless fragmentation. Democritus wanted something that could not be divided, and perhaps, in a way, he was right, but not about atoms. Instead, the true indivisible thing might be the rules that govern how particles behave, the laws of physics that seem to hold everywhere we look. While particles split and multiply, the principles tying them together remain astonishingly consistent. The Standard Model might evolve, but its core idea that an underlying order explains the chaos echoes what Democritus intuited millennia ago. The atom is no longer the indivisible bead imagined by the Greeks. It is a stage where quarks whirl, leptons flit, and bosons mediate silent conversations. It is a microcosm of the Standard Model, a testament to how far our curiosity has carried us, and how much further it might yet take us. The Greeks named the atom atomos, believing they had reached the bedrock of reality. But the true story of the atom is not about finality. It is about discovering that beneath each answer lies another question, and beneath each layer of matter lies a deeper layer of mystery, waiting to be split open. Whether matter can be based on a single and unique particle is a question we don't know if we'll ever get an answer to. But the hunt continues.